Combined gas law. In this video, we're going to talk about gas problems involving pressure, temperature, and volume. Often gas law problems include all the variables. Use the combined gas law formula when all the variables pressure, volume, and temperature are included in the problem. The combined gas law is P1 times V1 divided by T1K is equal to P2 times V2 divided by T2K. Remember, the T is there to remind you to use the Kelvin temperature. For example, a weather balloon is filled with 1 liter of helium at 49 degrees Celsius and 1.0 atmospheres at Death Valley, California. What volume does the balloon have when it is risen to a point in the atmosphere at a height equivalent to Denver, Colorado, where the pressure is 0.820 atmospheres and the temperature is 32.5 degrees Celsius? P1 is 1.02 atmospheres. V1 is 1 liter. T1K is 49 degrees Celsius plus 273 to convert it to Kelvin, or 322 Kelvin. T2 is 32.5 degrees Celsius plus 273, or 305.5 Kelvin. P2 is 0.820 atmospheres. V2 is question mark. The combined gas law is P1 times V1 divided by T1K is equal to P2 times V2 divided by T2K. I'm going to solve for V2. So I can say that P2 times V2 divided by T2K is P1 times V1 divided by T1K. To isolate V2, I will divide both sides by P2 and multiply both sides by T2K. So that my rearranged formula is V2 is P1 times V1 times T2K divided by T1K times P2. Make sure that you substitute in properly. You need to put T2 on the top and T1 on the bottom. V2 is equal to 1.02 atmospheres times 1 liter times 305.5 Kelvin divided by 322 Kelvin times 0.820 atmospheres. V2 is equal to 1.18 liters.